It's absolutely incredible and so exciting to be here. I cannot believe that we're all able to get together more than a year after things have happened in a certain way. And I want to start by just congratulating and thanking the staff and the organizer team. I think they've done an incredible job at keeping us safe and bringing us together to talk about this very important topic, which is cloud native technology. So just a round of applause for the organizing team. But also for all of you here that you made the effort and you showed up to learn more and interact with each other. And as Chris briefly mentioned, I just recently changed roles. So I'm now, I used to be a cloud advocate, and I'm now in a product management role. So it's a completely new career path for me. And if any of you here is working as a product manager, please reach out to me, and maybe you can share some tips and tricks. I'm excited to learn from you all. And you're all in this room here, so I'm going to start with one of my favorite paragraphs in one of my favorite books here. And I would love for you to think about whether you're recognizing it. So, a race of hyper-intelligent, pan-dimensional beings once built themselves a gigantic supercomputer called Deep Thought to calculate once and for all the answer to the ultimate question of life, the universe, and everything. And for 7.5 million years, Deep Thought computed and calculated, and in the end announced that the answer was, in fact, 42. And so another even bigger computer had to be built to find out what the actual question was. And this computer, which was called Earth, was so large that it was frequently mistaken for a planet. Sadly, however, just before the critical moment of the readout, the Earth was unexpectedly demolished by the Vogons to make way, so they claimed, for a new hyperspace bypass, and so all hope for discovering a meaning for life was lost forever. Anyone can guess where this paragraph comes from? Go, go, go. Yeah. Anyone else has any other ideas? Go ahead. Yes, that's right. So Hitchhiker's Guide to the Galaxy. And to be exact, I think this is from the restaurant at the end of the universe part of the Hitchhiker's Guide to the Galaxy. But the other interesting part about this paragraph, as I was reading through it, I was like, well, this kind of sounds like serverless a bit, right? Did anyone have that thought as well as they were reading through or listening through this paragraph? Yeah? That's too nerdy, possibly. But do let me know what other patterns you've identified after the talk here. So, my name is Simona Cotin. As I mentioned, I'm a newly product manager working on Azure Static Web Apps. I used to work in the cloud advocacy team, and other projects that I've contributed to are, so I've been a core member of the Serverless Days London team. I've also created 25 Days of Serverless, and I've helped lead efforts like Serverless September. So as you can tell, I have quite a strong passion for serverless, and I've been benefiting from using serverless for quite a while in building applications. So serverless use cases and workflows, I'm assuming you're interested in this topic since you're here. And to get started with this, you don't really need to go any further than this actual community that you're part of here, which is the CNCF. They've actually, folks at CNCF have worked on a white paper focusing on serverless, where they really explore what are some of the benefits of serverless, what are some of the use cases and types of applications that you could be building, together with a lot of examples that would be helpful to read through. So I highly recommend that you check out this white paper from CNCF. It's available on GitHub. And they identify a couple use cases here that might be worth keeping in mind. So when you're considering whether you should build your applications using serverless, you should evaluate whether your workloads are asynchronous and they're easy to parallelize into independent units of work. So that would be one type of use case for serverless applications. Another type of workload that might be useful to implement using serverless patterns is if you have infrequent or sporadic demand for your application with maybe large and unpredictable variance in the type of scaling that you're looking for. So think about maybe Black Friday and then the next day absolutely, or maybe just a much smaller number of requests. Usually you would use serverless for these types of requests. Stateless, ephemeral, and without a major need for instantaneous cold start time. So here, if latency is extremely important for you, so if you have to have very fast responses, maybe serverless is not necessarily the choice for you, because sometimes you might be experiencing cold start, especially when you have those very infrequent requests. And another thing to consider is whether you have highly dynamic terms of changing business requirements that require your developers to really create a lot of POCs and share new applications very frequently. So that's another place where you would use serverless for your prototypes and for very fast-paced changing requirements. Now, how many of you have used serverless in the past, just to get a picture? Okay, so maybe it's like 25% in the room. And how many of you have at least heard about serverless and are familiar with the main concepts behind serverless? All right, so that's probably half of the room. So I'm going to spend just a tiny minute to explain for the rest of the half of the room what are some of the key things behind serverless. So first of all, serverless is event-driven. So usually what happens is we trigger a request, which in turn, it drives a function to execute, and it drives our code to execute. And in order to do that, we usually use a platform provider that will basically provision the infrastructure that's needed for our code to run. It will execute that code, and then the instance is being killed, basically. And then another thing to know about serverless is that the code that you need to write needs to be stateless. So you cannot persist state in between function calls. You cannot rely that, let's say, if you're using a connection to a database, it will be forever available in the function code. You have to always create that connection. And something else that might be very interesting to learn about serverless as well is that because of this property of we provision an instance, we run your code, and then we terminate it, you actually pay only for the resources that you're using as you're executing that code. And that means the CPU time, and the other dimension is how much memory you're using. So you pay for what you use, and a lot of the platform providers will have a very generous amount of invocations. So, for example, I think for most of the platform providers, the first 1 million requests a month are cost zero. So you're going to be able to get away with a lot of experimentation and a lot of code, basically, or executing serverless functions without actually paying anything. So that's a brief overview. Now, I mentioned the CNCF white paper, where there's a lot of data and a lot of information around when should you consider serverless for your workloads. If you are interested in also learning about production serverless workloads, the Azure Functions team, together with the Microsoft research team, they published a white paper looking into more detail at a couple things. So the goal of the paper is to create awareness about what actually happens when a public cloud provider is running serverless workloads. And this paper focuses really on a finite time frame. So all of the serverless requests and invocations that have happened over 2 weeks back in 2019, and it looks at different dimensions. So it looks at the number of invocations, the type of functions that have been executed, and the amount of time that those invocations took. And another goal for this paper is also to basically understand how can we improve cold start time, because as you can imagine, there's a somewhat of a tension between the fact that serverless is a cheap technology and the price for serverless is very low, but at the same time, which means that cloud providers need to make sure that they're using resources very, very smart in a way that they can still make profit even when they offer this technology for such a low price. Which means in turn that they have to be very smart about how they're provisioning the infrastructure that runs your code so that they don't waste any resources. And as you might imagine, there's very little common patterns and there's very little predictability in how people execute serverless code. One of the key characteristics that we mentioned earlier were around infrequent and unpredictable workloads, right? So how do you make sure that your users don't experience cold start and you're still able to smartly allocate those resources? Usually what happens is, or what this paper has demonstrated is that it's smart to have a combined policy of really pre-warming instances and keeping them alive for a certain amount of time. So when we're pre-warming those instances, that means that our users will experience basically no cold start because our code is immediately executed on those instances. And if we keep them alive for a certain amount of time, then that also means that we can potentially reuse some of that state in between those calls. So we are also optimizing. It's a very interesting paper to give it a read and understand a bit about how this is actually implemented in practice. So I highly recommend you check it out. It's available online. One of the findings was that HTTP functions and HTTP requests are actually the most popular types of functions as well as the most popular invocations. So most often people are building HTTP triggered functions and most invocations happen as HTTP requests. You can also see that a very small percentage of those functions are really listening to events, so things like event-driven triggered function. I'm not sure what the AWS equivalent is, but maybe someone here, I see a t-shirt, I don't know if... But what's interesting with the event-driven functions is that even though they represent a very small percentage of the number of functions, they're actually the third most or largest in the number of invocations, which tells us that we use serverless to process a large number of events, where we use serverless to build applications that process a large number of events. Something else that might be interesting to notice is that timer timer-triggered functions, which are the cron jobs, the traditional cron jobs, they are a larger number of percentage of functions. But actually, when it comes to how often do we call them, it's a very small percentage. You can see here it's 2% compared to 24% event-driven or 35% HTTP-driven. And for this paper, there's the actual data that was gathered between July 15 to July 28th, 2019 is actually available on GitHub. So you can even go look at the data that's anonymized. But it really includes invocation counts, execution times, memory usage, and metadata like what's the event source or what's trigger type. That's how we call them in Azure. For every function invoked across Azure for the days that I just mentioned. And there's also a data set that focuses on the VM aspect of it. All right, so we just learned that HTTP requests are the most common types of workloads in serverless, which makes us think about serverless APIs, and this is one of the most interesting use cases that has enabled a lot of, especially front-end applications. How many of you have written client code like front-end applications here? Okay, so I'm seeing probably half of the room here. The other half, I hope you're all excited to see Gatsby application. But before we dive into that, I want to spend just a second to talk about this modern way of building websites and applications. That's the Jamstack, basically. And I don't know, I know, Chris, we talked a bit about the Jamstack. How many of you are familiar with the Jamstack concept? Okay, a lot less hands. So Jamstack, it stands for JavaScript, APIs, and markup stack. So that's the Jam and stack. And it's a modern way in which more and more web applications are being built. And this is a diagram from the jamstack.org website, where you can see here the traditional way in which we usually build applications, which is we have a client that makes requests to the web server, and then maybe we make requests to other app services and servers, and then we connect to a database, and maybe we also read data from a CMS. And with this new pattern, we're actually distributing all of our web or client application assets directly to a CDN. So rather than using a web server to host our, let's say, React or Angular application alongside our Java or .NET application, now modern web applications take advantage of CDNs to connect to our users closest to them, basically. So then what that means in practice is that we have our user that uses a browser, right? And it makes a request to our front-end application, and that request goes directly to a CDN, and we download those resources and we execute them in the browser. And in order to add dynamic behavior on the back end, we might be making calls to microservices, which sometimes might be serverless APIs or some other third-party services and third-party APIs. And you might be wondering, why is it that we're maybe preferring this new approach, or what are some of the benefits of this new approach? And a couple of them are, first of all, we get better performance. So rather than having our assets being built for each request and then distributed to our clients, we now pre-build and we pre-render some of these assets and we deploy them the closest to our users. So our content developer network node. Delivery network, CDNs, they usually have like a huge amount of points of presence across the world. Like I know Azure Front Door has more than 100 points of presence around the globe, which means that we basically cover the entire world. And if you're a user in Australia or a user in the US, you're going to experience exactly the same speed for your application, for my application that I've just built, because that content now sits much closer to our users, and that the static assets get automatically deployed and duplicated across all of these points of presence in the Jamstack. We also get higher security, because a lot of the server-side processes are abstracted into these microservices APIs. We have a smaller surface area for attacks, but also, especially when our assets are being pre-rendered with things like Gatsby or Next.js or other static site generators, that also means that when our users are making requests to our application, they're not accessing the database anymore. So everything all of the data was pre-built into our static assets at build time. So we connected to our database and to other services and APIs at build time. So there's no actual interaction with a server-side service sometimes when users are interacting with our client applications, because everything is already baked in. So there's no way to actually attack our database or some of our backend services. Of course, because we are deploying our static files to CDNs, our application is much more scalable, and it's also usually a bit cheaper, because we no longer have to provision and over-provision infrastructure in order to meet different types of demands for our applications. And one of my favorite parts is actually the better developer experience. So you will see that with Jamstack, a lot of the platform providers have baked in incredible developer tools and experiences. What happens most of the time when you're building applications for the Jamstack is you write code, you push it to GitHub, and then the entire deployment, CI/CD process, and the duplication over different CDN points, it just happens automatically. As a front-end developer, you don't have to worry about any of the infrastructure behind all of these resources. You just get everything out of the box. So APIs put the A in the Jamstack. And this is what enables us to add backend dynamic behavior to our client applications. I think in order to fully be able to develop complex applications like e-commerce shops, we really need to be able to add things like authentication and payments and a lot other types of services. So we need to be able to implement those in a scalable manner as well. And most of the times, in the case of Jamstack developers, we usually use third-party APIs. So think about Auth0. That's a no-brainer, or Active Directory, where you really, rather than implementing the whole authentication process within our own stack, we decide to use third-party APIs that are scalable. We pay for what we use. So these are backend as a services, and they're also part of, or they're core tenants in the serverless ecosystem, where we need these managed services to scale alongside our own custom serverless APIs and alongside our client applications. And I want to show you how this actually works in practice. And is anyone here Danish? No? I know that's an odd question to ask, but I recently read this book about hygge, which is a term that folks in Denmark use a lot to express well-being and everything that's related to happiness and well-being. It has something to do with hygge. And part of what it takes to create an hygge atmosphere is lights. So Danish people love their lamps, and I'm showing here an e-commerce website built with Gatsby. It's a static web application that is also an e-commerce application that allows us to buy lamps. And you can see here that we have a list of products. We have functionality for sign up, sign in, and shopping cart. And all of the authentication and e-commerce side of things is actually a platform that's called Molten e-commerce, and it's a headless e-commerce. So all of this functionality is provided through APIs by Molten e-commerce. But I want to go further, and I want to customize this application, which is, I haven't built it myself. It's a Gatsby starter application. So as a front-end developer right now, you can just go to Gatsby and say Gatsby init, and you use a template, and it gives you this fully baked application that looks beautiful, and you can change it and create your own e-commerce application very easily. So my extraordinary customization is actually that tiny button or link at the bottom, which is called contact. And the goal there is to give our users an opportunity to send us a message. Especially for the Danish folks that love their lamps, they can say, hey, I love that you have this model. Thanks so much. And to do that, can anyone guess what I'm going to use? Serverless APIs. Okay, and let me just, first of all, I should have my mirror display. Okay, perfect. And this is my Gatsby application. This is a live demo, so keeping my fingers crossed for the internet gods as well as that everything works. And in fact, I've done this in the past. I'm just going to copy and paste codes just to give you the idea of where things are positioned so that you can maybe have a picture for what needs to be done. So this is our Gatsby application that is running. And as you can see here, it's running in my local host 8000, and currently we only have the privacy and terms in the about section. So our goal is to add a contact link there, as well as a serverless API. And the reason why we need a serverless API is because in order to send an email, we're going to use this service called SendGrid. Is everyone familiar with what SendGrid does? Okay, I can see a couple hands. So SendGrid allows us to, it's a third-party service that will send emails for us. And you can basically import a library and send that email very easily. And in order to create a new API, I'm actually going to use Azure Static Web Apps. As I mentioned in the beginning, I'm a new PM on the Azure Static Web Apps team. So I'm going to make sure to show in VS Code how we can add an API endpoint in our Gatsby application. And in VS Code, we have this thing called VS Code extensions, and a lot of the Azure products have these extensions that allow you to quickly generate code based on certain templates, as well as quickly connect to the cloud and maybe manage some of these resources directly from VS Code so that you don't have to go to the actual UI of the cloud provider. And what I'm going to do here is basically create a new function, generate a new function. And the first thing that it asks me is, what type of language do I want to use? So you can use JavaScript, TypeScript, C#, and Python. These are the ones that are supported directly by Azure Static Web Apps, and they're managed by Azure Static Web Apps. Azure Functions supports other languages as well, like Java and F#, for those of you that use some of those. So I'm going to use JavaScript, and I need to give my function a name, contact. And this is going to be an HTTP triggered function. So we're going to listen to HTTP requests. And we can see here that a new folder has been added directly into my client application. And it's called API. And in here, I have the folder contact, which is basically my the folder where my function lives. And this is just an index file where we wrote the code for our function. It's a hello world that's generated by the Azure Functions templates. And a couple of things to notice here is that we have a package.json. So this is where we manage our dependencies in Node.js. And we can install new dependencies directly in our local and run our function. Here, local.settings.json, this is where you can specify some of your secrets. So let's say when we're going to connect to our SendGrid API, we're going to have to, rather than using our secret or environment variable into our code, we're going to put it into this local.settings.json file, which allows me to run and debug my functions locally. And then when we move this to the cloud, we're going to have to edit some environment variables directly in the cloud. And I mentioned that I'm going to copy and paste code. But before I do that, I'm just going to show you how we can run this function locally. Something that might be worth keeping in mind is also that Azure Functions is a runtime is an open source project. So the reason why I'm able to run this locally is because the function codes or the runtime is open source. So through Azure Core Tools, we are installing some of this, the runtime, and we're able to run things locally. Ignore that. And you can see here that I'm given the URL at which I can call this function. So I'm going to copy this, maybe add a breakpoint, and then I can go into my local environment, paste the URL, and we can see already that my application has stopped at this breakpoint that I've set earlier, and it says that my name is undefined, and that's because I haven't passed any query string to my URL, which is what this function expects. So maybe I can add here Liz. Wait. Name. Liz. And I think that should be okay. So now my name is Liz, or we want to say hi to Liz because we're grateful for Liz to be here. And then when I continue running, you can see here that it still tells me to pass a name. So I've passed the name and wait, sorry? Yeah. Oh, but because I passed the name here, it actually says, "Hello, Liz. This HTTP triggered function executed successfully." So this was just a quick example of how you would create a new serverless function that you can connect to from your front-end application, and how you can run and debug it locally using VS Code. And the next thing that we want to do is actually make this a useful function. And to do that, I'm going to go into my previously created application. And I don't know how many of you are familiar with this. It happened a couple weeks ago. But if you go to GitHub and you click dot, does anyone know what will happen? Yeah? Code spaces. OK, so we're going to just immediately see our code directly into VS Code, and we can explore it here. And I'm going to copy, first of all, this contact.js, which is a page in Gatsby. And that goes into source, pages. We don't have the contact page here, so I'm going to add a new one, contact.js. And really what we're doing here is we are creating a form. And the key thing is that we are, in order to send a message, we are making a request to API/contact. And I think what's important here is that, as you can see, we don't have, like, we're using a relative path to where our client code is. So both our function and our client code get deployed together. And the platform makes sure for us that we have the right URL in place. So I've created the contact.js file, and the next thing that we want to do is, in our components, in our footer, we want to add our contact link. Because we want it to be visible. And that will be under terms here. And finally, our API function. So this is where I'm actually running the custom code. And I need to install the SendGrid dependency. And to do that, I'm going to run npm install add SendGrid /mail. So this will add into my package JSON the SendGrid dependency. And then I mentioned that we have this SendGrid API key as well that we need to set in order to successfully connect to SendGrid. So I'm going to go ahead and define it into our local settings.json file. And I will copy it from the previous function or static web app that I've deployed. So I will go into application settings, and you can see here that I have this setting. I'm just going to copy it. Please don't use my SendGrid API key. That was not secure at all. Okay, paste it here. And what happens in this function is really we are getting the message from our request buddy and sending an email to simona.cotin@gmail.com, adding a subject and then adding some text. And then we're making a request to SendGrid and then sending back to our client code a message like email sent. So let's go ahead and deploy this. Does anyone want to guess how I'm going to deploy my application? What's been most useful so far? Sorry? That's a good one. Yes, we're going to have to do that as well, because as I mentioned, as a Jamstack developer, what you usually do is you push your changes to GitHub, and then the platform handles everything for you. And in order to do that, I'm going to actually use VS Code and the Azure Static Web Apps extension. So I will... Okay. And I will create a new Azure Static Web app called Gatsby Store. And then it's going to actually create a GitHub repository for me. So rather than saying GitHub Store, I'm going to call it e-commerce. And the region that I had to specify is actually for Azure functions, so that we know a location where we're going to deploy our production functions. And then the next thing that I need to define is what type of application am I deploying, so that the GitHub action knows what type of build to run, where the application code is, and where my static files will be generated. All of this is default for this application. So now I can go ahead and edit this GitHub action directly in VS Code, it's been created and pulled back into my now GitHub repository in my local environment. And this is a GitHub action and workflow that you own, or I own now. Like, I can customize it as far as I want to. This is just the first step that allows Azure Static Web Apps to build my application and deploy it to the cloud. A couple of things that are needed here are the API token that allows me to deploy my application, the repository token, which is a secret in GitHub, and then these 3 settings that we've seen earlier that allow us to define the app location, the API location, and where the static files are going to be generated once things are built. And that's it. After that, I can customize whatever I want to. And if I go into GitHub, I'm going to be able to also see the GitHub action running in my e-commerce repository. And we can see here that it started a minute ago. We can inspect the steps. Now, this is a relatively complex application. As you've seen, there's a lot going on. You've only seen the one bit about the serverless function and the page that I've created, but actually it's quite a big application. So it takes about 4 minutes to build and deploy everything. And I'm just being let know that there's 5 minutes left. All right. So, the application is live at Shop at Home XYZ. And it has the custom domain. We have this contact page. And I'm able now to say that these lamps are lovely. And I can send a message, and here in my Gmail, there should be a new message saying that Simona Cotin sent an email. All right, going back to our slides. There's a couple more things that I wanted to talk through, and we've seen the demo, we've seen the code, and something else that that I wanted to talk briefly about is stateful workflows. I've mentioned that serverless is actually stateless, and we cannot rely on state being preserved in between function calls. But most of the times, in order to build meaningful applications, we need to be able to pass state from one function to another. And these are the principles I've mentioned. Functions must be stateless. Functions don't call other functions. And we also need to abide the single responsibility principle. So usually one function should do a single thing in serverless, which makes our job quite difficult if we want to be serious about using serverless for complex applications. And this is just a simple example, like how would we go about implementing two-factor authentication using serverless? This was an exercise for all of you to think about this, but I'm just gonna go straight to a potential solution, which is we might need to have two different functions. One is to generate the actual unique code and then store that code into maybe a database or table storage, and then we also need to have a different function to verify that code, and they need to read that data from our separate storage. And I think something that I wanted to point out here is that even for this simple task, it's actually a lot to take in. Like here we have this beautiful diagram that we can reason about what happens in our code. But actually, when you look at the cloud provider and you look at these resources in your terminal or in your UI, things are not going to look as nicely. They're going to be a list of resources, and we're not going to be able to fully understand immediately how are these resources connected and how do we think about them. And then taking this one step further, if we need to debug this application, it's going to be difficult to trace everything through each of these functions. And of course, we have tools like maybe Epsagon or Application Insights and others. So we have to introduce yet another tool that helps us reason about this small part of our application. And that makes it a bit tough, a bit challenging, right? And there's even more complex types of workflows that we can think about. Like one easy task or relatively easy task where serverless is actually a very good fit is this pattern of maybe doing a task once a day where we do a database cleanup, right? Where we execute all of these functions in parallel that will read data and update it or clean data for us. But then most of the times we need to have an aggregation task as well, where we update a field in a database saying that these tasks have finished. And how do we do that easily with serverless? It's actually not that straightforward. And another type of workflow, imagine in an organization, you have to expense, let's say travel. We all came here to this wonderful conference, and sometimes it might cost a lot more than if you're traveling from Austin and the US, it's going to be a greater cost than if you traveled from Zurich. And sometimes you need to do that. You need to send it an approval, and you want to have a human approval. And with serverless, it would be difficult to have this like coordinated set of tasks where an expense is sent in, you get the human approval, and that triggers another set of tasks. And I wanted to introduce durable functions, which is allows us to build stateful workflows using Azure, on top of Azure functions, and it simplifies how we write them. So there's already solutions for these problems, things like Azure Logic Apps or Amazon Step Functions, but the challenge with those is that they're UI designers. Whereas as developers, most of the times we want our code to sit in source control, we want to be able to use CI/CD, and durable functions helps with that, where now you can use the Azure Functions programming model using your programming languages like JavaScript or Python or Java, whichever your choice is. And basically we have workflows as code, and we have abstractions for these common types of workflows, and a reflective API that allows us to query the status for those jobs. And the architecture is based out of a reactive core, event sourcing, and our code for orchestrators need to be deterministic. And these are the type of functions that I mentioned. So we have an orchestrator that will basically contains our workflow, and the serverless part of this is the activity function, which are stateless, while the orchestrator is a stateful instance. And I'm going to finish in half a minute. So this is Spirit Dog is an application that I built. You can find it on GitHub, and it showcases how you can train AI/ML models that will basically tell you what kind of dog your face looks like. And this is inspired from Parks and Recreation. I'm not sure if you're fans of Parks and Recreation. It's one of my favorite shows out there. And it will just give you a probability of whether you look like a silky terrier or not. And this is how we define our workflow. The code looks very straightforward. So this is how you would define an orchestrator in JavaScript. You basically use the same programming syntax that you would use in other paradigms. And this is the activity function that allows us to make I/O operations. And the code for all of this is on GitHub. It's called Spirit Dog. And a couple other use cases are things like calendar apps. And my colleague Anthony, too, created another type of workflow where we're now able to detect whether we're seeing a cat or a dog in a picture. I hope that was useful and inspiring, and please reach out to me if you have any questions. So long, and thanks for all the fish.